Hello everyone, so we are from group 4. So my name is Avinash and this is Kavidan and then this is Kalirovan and the person who holding the camera is Loganeshit. So today we are going to discuss about our project. So our project is about IoT based smart chicken farm monitoring system. So basically chicken farm faces several challenges such as uncontrollable temperature and humidity, which lead to health issues in chickens. So high humidity level in chicken farms can lead to growth of various bacteria and fungi, which can causes respiratory diseases in chicken. So for example, disease especially coryza. So basically coryza is a bacterial infection which grows in chicken in humid conditions. So the disease can cause breathing difficulties, facial swelling, nasal discharge and reduce egg production in chickens. And also when the temperature in chicken farm is too high, it can cause many problems like dehydration and heat stress in chickens. So this problem can lead to several health problems and reduce productivity. Additionally, the release of harmful gases like carbon dioxide and ammonia can create an unhealthy environment for the chicken. Current monitoring system lack the ability to provide real-time and accurate data on these conditions, making it difficulty to farmers to take the proactive measures. So therefore, an IoT-based smart chicken farm monitoring system is needed to address the challenges and ensure the health and productivity of the chicken.
Machine can get a source of protein easily and very cheaply. Chickens and eggs are main source of protein in Malaysia. According to data provided by researchers, each nation consumes about 50 kg of chicken meats and 370 eggs in 1 year. Chicken is the most popular meat in Malaysia and provided by 3,000 chicken farms around the country. The main purpose of our project is to develop a system that is able to measure the temperature, the humidity and air quality of the chicken farm in order to guarantee the good health of the chicken and well-being of the chicken. And the second is to monitor temperature, humidity and air quality of the chicken farm. From this project there are many beneficial such as for the chicken farm owner and help global food chain supply.
So the scope for our project is selecting appropriate sensors that are required for monitoring the temperature and humidity levels of the chicken farm. Sensors will be needed to be able to measure temperature and humidity accurately and be durable enough to withstand the conditions of the farm. We will be able to implement a temperature and humidity sensor and also an air quality sensor in our project. Chickens are a kind of a domestic birds which needed some specific requirements for its breeding. So chicken eggs need to be hatched in between 37 degrees Celsius and 38 degrees Celsius. Also the air quality has to be maintained in order for the chickens to not be intoxicated. So the air quality sensor would be programmed to detect those toxic gases for the farm owner.
So the task for our group member will be to build a prototype for our proposed project. So for this project we are planning to use microcontroller. It is an Arduino Uno and we are using some sensors. It is a DST11 and a MQ135. So Arduino Uno will be the main board where all the sensors will be connected, and DST11 sensor will be detect the temperature and the humidity for the chicken farm. Then we using MQ135 to capture the air quality in the farm. So and also we are using a Blink app and a ThinkSpeak to monitor and visualization for our project. Thank you. This is our first video log
For this week.
for this
Thank you
week.
so much.
Thank you so much.
Hi everyone, so this is our video log 2. So in this video log we are going to present about our hardware and software that we are going to implement in our project.
So now I'm going to explain about the main component that we're going to use in our project. So the first is a microcontroller that we are going to use is Arduino Uno RVE3. So this will be connected to the sensors, and then we will code everything will be in this microcontroller. And then next is we are using a not MCU ECP8266. This is a Wi-Fi connectivity. So let's say we are having cloud services or any other services will be connected to this, and then other services will be like application or monitoring remote monitoring will be connected to this. And then next will be Arduino connectivity wire. So this will be useful when we want to connect Arduino to the laptop or PC. So we will use this. And the next is an adapter for Arduino Uno for a power supply. That's all.
Here I will explain what sensors are we going to use to our project. The first sensor is MQ135. This is a gas sensor can detect gases like ammonia, sulfur, benzene and carbon dioxide and other harmful gases and smoke. And this sensor also digital and analog output pin. When the level of these gases go beyond a threshold limits in the air, the digital pin goes high. Next sensor is DHT11. It's a basic and ultra low cost digital temperature and humidity sensor. It's used a capacity humidity sensor and a thermometer to measure the surrounding air and spit out a digital signal on the data pin. That's also three.
I will be explaining 3 components that will be used for our project. So, a buzzer, breadboard and an LCD. The buzzer will make a sound when the temperature and humidity goes either too high or too low. The breadboard will be used to make a prototype of our project, so it will be connected to the sensors and the Arduino. And the LCD will be used to display the temperature and the humidity or any other toxic gases that will be in the chicken farm.
Hi, I'm going to present about the software that we are going to use and implement in our project. The hardware part, Kavilan, Kadiruvan, Loga already discussed about the hardware that we are going to use. Now I'm going to discuss about the software. This is our first software that we are going to use. This is Arduino IDE. So the Arduino IDE is a open source software. So we can use to write and upload code to Arduino boards. Then the Arduino IDE provides a user-friendly interface. And then we can write code in the Arduino programming language, which is based on C and C++ programming language. So the IDE also includes a code editor, which features such as syntax, highlighting, auto-completion and error checking, like other compilers. Then the other software we are going to use is ThinkSpeak. So ThinkSpeak is an open source software also for Internet of Things platform that allows to collect, store, analyze, visualize and act on data from IoT devices, and it provides an easy to use interface for developers to connect their devices and sensors to the internet. And we can also store and analyze data that generated by those devices that we are going to use, like MQ135 and DHT11. put up all the hardwares like MQ135, DST11, LCD, all these to our Arduino Uno board. Now we are going to test the MQ135 sensor. So we are going to use a lighter. So yep. So if you see in the LCD board, so the ppm is now is increasing. So if the ppm is less than 10, the green LED will be turned on. So if you see in the board, now the ppm is 0.84, so it's under 10. So the green LED is turned on, and the red LED is turned on. And the ppm greater than 10 and less than 20, it will be the green LED will be off, and then the red LED will be on. So, and if the ppm is greater than 20, it will the green LED will be off, and then the red LED will be on. So for the testing, we only set the ppm for 10, but for real one, we'll be set the ppm to 1000. For only the testing purpose, we only use 10 ppm and 20 ppm.
Now I will explain about DST11. For DST11, the temperature must be around 18 and 33 Celsius. If temperature is below 18, the red light will be on and buzzer also will be on. And if temperature is higher than 33 Celsius, the red LED will be on and buzzer also will be on. For humidity, humidity must be around 60 and 80. If humidity is below 60, the red LED will be on, and if humidity is higher than 80, the red light will be on. Now we will test the DST11 sensor. If temperature is above 33 Celsius, the red light will be on and buzzer also will be on. Now its temperature is 34.20 Celsius. If temperature is below 33, it will be turned off. That's also.
Hi, this is video log 4. So now we are going to present all the steps that we have been do to create the cloud-based visualization. So first, to send sensor data from Arduino Uno to Node MCU, so we are using a serial communication protocol. So yep, here this is the code that we are using to send the sensors data like temperature, humidity, and then air quality data to the serial port. Then in the Arduino IDE, we so basically we write a code, and then to read the sensor data and send it over the serial port. Then we upload the code to Arduino Uno. After that, we also write another code. We write another code to read the sensor data from the serial port in Arduino IDE and upload in Node MCU. So to verify the sensor data is being transmitted and receiving correctly, so we're using serial monitor to verify that. So yeah, here the data that we got from the MQ135 sensor and then DHT11 sensor. So these are all the data that we receive from the node MCU. Then the data that we receive, we will send to the ThinkSpeak. So that part will Roga will explain to you.
So now I'm going to explain how the data is sending to the ThinkSpeak from Arduino. So first we are using so now we are using how to connect our ThinkSpeak to the Arduino. So we are using this URL. So URL to connect our ThinkSpeak to Arduino. So we get this URL from ThinkSpeak. We go to API key means. So from here we can get the URL here. So write a channel feed. So from here we can get the URL. So it's basically it's a read API keys. So after this, if you want to see the reading from the sensors to here means like a visualization graph, so we can get here. So for this, the first graph is for the temperature, and then the second graph is for the humidity, and then the third graph is for the air quality. So if you can see here, the graph is reading for a day, so it will showing the time here. So this is the reading. So the reading is actually showing over here, so you can see the data here. So the last thing is 32 is showing that 32 and 0.30 is showing the temperature, and then the 70.00 is showing the humidity, and 3.81 is showing the air quality. So if you can see here, the air quality, for example, the air quality is actually accurately showing from the same thing is showing here. So here it's 3.53, and for the Arduino you can see 3.53. So the data is every minute is showing, it's collecting the data. That's all. This is our final log. So now I'm going to explain our final prototype, the working prototype of our project. So now I'm going to explain what are the hardwares that we have used for our project. So we are using our microcontroller as Arduino Uno, and then breadboard, and MQ135 as a gas sensor, DHT11 as a temperature and humidity sensor, and LCD to display all our data, and not MCU for our Wi-Fi, and buzzer to beep to indicate our the data. And I'm going to explain how this MQ135 is working. So now I'm going to show this working type. So for now we have connected our MQ135 to our breadboard to the Arduino. So this is our display, and the top one is showing the air quality. So now it's showing that F is equivalent to fresh air, and the ppm is actually fresh now. So now I'm going to use this gas to increase to show how the thing is working. So if you can see now, we're using our lighter to give gas. So now you can see it changed to danger, and then the LED is working. So show again. Okay, you can see now once the ppm is increases, you can see the LED is working, and now it back to the green light. It means it's showing that it back to the fresh air. So for this thing, if F means it's showing fresh air, if you go to poor means it will show, if show to P means it will show poor, and then D means it's danger. So if fresh air means the normal ppm for the chicken farm, it have to be below 20. If poor means have to be 20, between 20 to 30. If danger means have to go to 30 and above. That's all. Now I will pass to Kavilan to explain about the DST11.
Okay, now I will explain about how DST11 sensor working. This LED is for temperature and this LED is for humidity. And this is a buzzer. Buzzer is for temperature. T equals to is temperature. Now its temperature is 29.80 Celsius and humidity is 80. For LED for temperature, if for suitable temperature for chicken farm is between 18 Celsius and below 34 Celsius. If temperature is below 18, the light will LED will light up, and if temperature is above 34, the LED will be light up, and buzzer also will be ring if temperature is below 18 and if temperature is above 34. For humidity, suitable humidity is 60 between for humidity is suitable humidity is 60 and between 80. If humidity is below 60, the LED light will light up, and if humidity is above 80, is also be light up. Now we test our temperature for. Now we are testing DST11 sensor for temperature. Now I will be disconnecting the buzzer. If temperature is higher than 34 Celsius, the LED will be light up and buzzer also be sound on. The humidity is now is 83 and the humidity LED will be light up.
So now I'm going to explain about the cloud-based visualization that we are using for our project. So basically we are using ThinkSpeak. So as I said in log form, the sensor data from to send the sensor data to Arduino Uno to Node MCU. So basically we are using serial communication protocol. So the sensor data, the sensor that we are using is DST11 and MQ135, right? So the sensor data that we get from these two sensors, it will be sent over serial port to Arduino Uno, and then from Arduino Uno it will be sent to the Node MCU, and then from Node MCU the sensor data will be transmit to the ThinkSpeak. So this is the data that we got from the sensors. So the first one is 28.90, that is temperature data, and then this one 84 is humidity, and 3.36 is air quality. So if you see in the ThinkSpeak, this is the temperature graph, humidity, and then the air quality. So the last data we got is 28.9. If you see here, it's accurate. Here also is 28.9, and then for humidity the last one is 84. So if you see here means in the serial monitor it shows 84, and then for the air quality the last data is 3.36. so if you see in the serial monitor it's same 3.36 here. So now Loga is trying to increase the temperature. Yep. Now if you see the temperature is increasing. Before this is 28.9, right? So now it's 29.30. If you see at here, it is also increasing from 28.9, it increasing to 29.3. So if you see, the humidity also is decreasing because Loga is tried to increase the temperature, so humidity is also decreasing. So before this it's 84, now it's 83, and it's decreasing to 79. So if you see here, the data, the air quality reading is 2.11. If you see in the ThinkSpeak, it's 2.11. Now Loga is trying to increase the ppm reading using lighter. So in ThinkSpeak, basically the data will update in each 15 second. The data will update on ThinkSpeak. So here, if you see, the ppm reading is increasing. Now it shows 5.11 here. So in the ThinkSpeak also it shows 5.11. So it's increasing. And then, so the air quality ppm is now getting to the normal. Now if you see, is 1.91, because Loga already stopped to release the gas from the lighter, so it's became normal. So yeah, that's all for the ThinkSpeak, the cloud-based visualization. Thank you.
Hi, my name is Avinash. I'm the group leader for my group. So our group project is about IoT-based smart chicken monitoring system. So working on this project was exciting and challenging experience. Our project is aimed to create a system that could monitor the chicken in the farm using sensors like DHT11 and MQ135. So during the project, our team faced some issues when we develop our IoT project. So one of the major problem I faced during the project was sending the sensor data from Arduino Uno to Node MCU and then forward it to the cloud. So the cloud that we are using is ThinkSpeak. For our project, we are using ThinkSpeak. So after some research and findings from the internet, we are able to figure it out, and also with my cooperation with the team members, we are able to overcome the challenge and create a functional system that met our project requirements. Overall, working on this project was great learning experience. It taught me the importance of collaboration, the teamwork with my group members, and importance of problem solving skill when working on this IoT project. Thank you.
Yes, so our project is based on IoT based smart chicken farm monitoring system. So the experience that I gained from this project is basically I'm not experienced in IoT based platform before. So from this project I learned something that I can know how to assemble Arduino from sensors and collecting the data from the Arduino, and from the data I know how to transmit the data to the cloud. So it's something new to me, and I learned much of things, how to connect the sensors, and how to use the sensors and the usable of the sensors. So it's something new to me. Thank you. That's all.
Good afternoon. In this project, I have learned about IoT devices which are always around us and used for certain purposes. And those IoT devices also can be used to solve everyday problems, such as for our own project, which is monitoring chicken farm system. So it will be helpful for the farmers to help and monitor their chickens. And also I have learned about how to learn and build the IoT project using Arduino and components such as sensors, jumper cables and breadboard. And especially in this project, it's about the teamwork with all those members and how we combine our brains to work together and complete this project successfully. That's all for now, so thank you.
1, 2, 3. Hi sir, my name is Kavilan. Our group project name is IoT based chicken farm monitoring system. The challenges we face in our project is we face some problem in coding in for Node MCU to ThinkSpeak to transfer data from Node MCU to ThinkSpeak. After few researches and watch some YouTube videos, we able solve the problem, and I also help doing the coding for DHT11 sensor and some part of documentation. From this project, I learned importance of teamwork, methods of problem solving and time management to finish our project. That's all sir, thank you.